Covers the sequences and series review, which is also known as Week 8 Task 1. So there are 10 questions in this review. They will help you prepare for the 6-question assessment review. In that 6 questions, you do have to make a 70 or above before the Week 8 Task 2, which is the accuracy assessment, will open. So number 1, the rule for finding the nth term in a sequence is x times x minus 2 divided by 4. What is the 5th term in this sequence? So what you're needing to do is replace x or n with 5 and then simplify this. So you can put it into a graphing calculator just like you see it. So to show you that option, you would do 5 minus 2 over 4. You could also simplify by hand. So 5 minus 2 is 3 divided by 4. 5 times 3 is 15 divided by 4. So either way, you can do it piece by hand, or you can do it in the calculator. Number 2, the expression below shows a pattern of numbers. Identify the first 5 terms in the sequence. So we start with 0 and then 1, 2, 3, 4, 5. So 0 is that number that is completely by itself. Then for 1, we are going to add 0.7, or you can also plug in like 0.7 times 1 plus 6.8. I'm just trying to show you a couple different ways depending on the technology you have at home. So if you have a graphing calculator, you could plug this whole thing in, so 0.7 n or x plus 6.8, and go to the table to see your values. You can also just keep adding whatever this is, or plug these numbers in for n. So if I'm just plugging in 0.7 times 2 plus 6.8 would give me 8.2. I can also just keep adding that 0.7, the whatever's in front of n, to the number that came before it. So if you notice, there's a couple different ways that you could knock out some answer choices. The first number needs to be the first number shown in your pattern. Everything else from there needs to be increasing by this amount. So plus 0.7, plus 0.7, plus 0.7 every single time. So to finish up, we have 9.6 and 10.3. And my numbers are a little bit off. So there are your first 5 terms. The following describes an arithmetic sequence where x is the number in the number's position in the sequence. What is the missing value for the table above? So missing value, I'm doing the same thing we did on number 1. I'm going to put 9 in for x and simplify. So you can plug this into your calculator, or you can simplify piece by piece. 9 minus 2 is 7. 3 times 7 is 21. You could also take this and put it in y equals and see when you go to 9 on the table. You could also put this, once you've rewritten it, put it into the calculator to simplify. Number 4, the pattern of smiley faces continues indefinitely. More smiley faces are added with each step. Write an expression that can be used to determine the number of smileys in the nth step. So when I'm looking at this table, I can see I go from 2 to 4, so I'm adding 2, to 6, so we are adding 2, to 8, so we are adding 2. So this is going to be a linear table. Now on all of your assessments, if we were expecting you to do stat edit, those steps will already be done for you, but I want to make sure you would understand how to do it if you had a calculator. So step 1, 2, Step 1, 2, 3, and 4. We have 2, 4, 6, and 8 smileys. So again, this step in the calculator will be done for you. So you will see something like this on the assessment along with this picture. So make sure if they ask you to write an expression and they show you the calculator, that you write out that expression in the calculator on your paper. So remember here we have y equals ax plus b. A is 2 and b is 0, and so we replace that for our linear function. Number 5, a study of flu cases growing exponentially seen in the table below. Write a regression to represent this data. So if you were to see this on an assessment, you would see the picture of the chart. So like we see on this paper right now. Remember, these steps are going to be done for you. It's an exponential regression, so I'm doing expreg. And then they want you to write a regression to represent that data. So this picture will be with the chart. It'll have your chart, and then the chart will have already been put into the calculator. So you really only need this picture. We have y equals a times b raised to the x. So that would be 4 times 3 raised to the x, and 3 will be in parentheses. Number 6, 8 friends recorded the following data about their height in inches and their weight in pounds. Write the line of best fit. So this one is linear for the table if it represents a quadratic function. Ooh, my bad. Sorry, quadratic. I bolded the wrong thing. So a quadratic function. This, again, the table will be given to you, and it will be worked out in the calculator for you. And you will just have to look at the calculator part and write your equation. However, we do know some of you have graphing calculators, so we want to be cognizant of that and give you the chance to work it out in your calculator as well. So this one is quadratic, so that would be 5. So this one's going to be really ugly. We're going to round, but we have ax squared plus bx plus c. So that would be 0.06x squared, and then a negative 1.94x plus 26.58. So again, because that one said quadratic, I did the quadratic regression. Remember that those regressions will already be done. So look at the chart, but really look at the picture of the graphing calculator. Number 7, Andre is the quarterback for his high school football team. During a game, he throws a pass directly down the field to another player. The height and distance of the football from the place it was thrown as it travels through the air is recorded at regular intervals and is shown below. Find the quadratic equation. So this one is just like that last one. So again, these will be worked out for you. And all you'll have to do is be able to look at the picture of the calculator and write out your answer. So on this, ax squared plus bx plus c. Please, please, please make sure, even though we're giving you the calculator part, make sure you're looking at that first line to see what the equation needs to look like. So negative 0.0625x squared plus 2x plus 0. The following is a geometric sequence. So remember, that means we are going to write an exponential equation. Write an equation below to represent the function for this sequence. So when I put this in, I have a 0, 1, 2, 3, and 4, just like we did in the last task. And then remember, I don't know if we for sure hit on this, and it won't be on your assessment, but if you see negatives on exponentials, you just leave them out and put it in at the end. So this one, because I am using the calculator, this calculator picture will also be provided for you. So I can see it is an exponential regression. They want me to write the equation. So I will have, it's a times b to the x. So 14 times 7 to the x. And then if you notice, this is changing, so it would be a -7. Don't stress about the negatives. Make sure you would be able, oh sorry, I'm not finished with my equation. Make sure you would be able to take this and put it into this. Now remember, geometric sequences have an x minus 1 because this is spot 0. So in order to get here, we have to put in a 0 here, okay? So make sure if you're looking at something like this, and actually 14 starts negative, so they would both need negatives. But make sure if you're looking at something like this, that the geometric sequence, look for something that has x minus 1. On that assessment, mark out anything that does not have an x minus 1 because those are there to try to trick you. Number 9, we have a sequence of numbers. A to the 2 is 2, A to the 3 is 5, A to the 5 is 11, A to the 6 is 14, and A to the 7 is 17. Based on this information, what could be used? So this, again, will be given to you. Remember that we put the little numbers in L1 and the big numbers in L2. And then this one should be linear. And so that printout would be given to you, and you have to write it in ax plus b terms, which would be 3x minus 4. And remember, with all of these, you can always check that little number is what goes in for x. So if I do 3 times 2 minus 4, do I get that big number? Pick another one. 3 times 6 minus 4 should give me 14. So don't be afraid to work backwards. If you have a multiple choice with a ton of a ton of equations listed below, plug them in and see if you get these. You could do that for number 8 as well. If I did 14 times -7 raised to the 1 minus 1, I get that first number, and I forgot my negative in there. But if I try it again, for that second spot, and let me go throw that negative in there, then I would get the second number. So don't be afraid to work backwards either. And number 10, a geometric sequence can be generated using a to the n is 5. Remember, this is my rate. And then we're a to the 1, so we start at 7. And n is a number greater than 1. What are the first 4 terms? So the first term was given to me. That number over here, a1, whatever a to the 1 equals, needs to be your first number. Then your rate, this is geometric, so we multiply. So that first number times 5 is 35. And then we will do it again. So in your calculator, you can do times 5 times 5 times 5. And that would be 875, and they've asked for the first 4 terms in that sequence.